Hello everyone. Today we will be implementing the support vector machines with the radial basis kernel in Rapidminer. So let's get started. So we will begin with our data, and this data is basically the data of a bank which is currently running a campaign to improve their bank term deposit. It has 16 numeric variables along with a results column in which there are values of 0 or 1, which basically identifies whether the customer subscribed to the campaign or it did not subscribe to the campaign. So in order to implement the support vector machine, we'll first insert the support vector machine operator into our process. So before we look at the different parameters, let's see on how the support vector machines performs. Start. So in this case, the simple support vector machine is basically a linear model which gives a function which is a linear combination of all the input variables. So how do we know that the support vector machine performs well? So in order to test that, let's add the cross-validation operator and see how support vector machine operates on the given data set. So we'll insert again our support vector machine operator over here. Now in order to apply this support vector machine model, we'll add apply model operator. Now remember that in our results column, we had the values of 0 and 1 to identify whether the customer subscribed to the campaign or not. And this classification is basically based on a probability which is generated by the support vector machine, and that probability basically tells us whether the customer will be subscribing or not. Now that probability basically acts as a threshold. So in order to implement that threshold, we'll add create threshold operator into our model. And in order to apply this threshold of 1 and 0, we'll also add another operator for apply threshold. In order to check the performance of our model, we'll add a performance operator into our model. And now let's see on how this works. So right now we are getting the results. Again, we have not changed any parameters up till now. So this is again a linear model giving us the predictions for all the different customers that were in the data set. Now, in order to get to the main subject of this video, which is the radial basis function, we'll look at different parameters that are available to us. So the first parameter is the kernel type. The kernel type that we'll be looking at is the radial basis function. It's basically a combination of Gaussian exponential functions, and their combination results in a nonlinear function. The other parameter is the regularization parameter, which is represented over here by the capital C. The regularization parameter basically tells us how much error is bearable, or in other words, how wide the margin would be between the support vectors and the hyperplane. For the particular kernel, the radial basis function, there is one more parameter which is the kernel gamma. The kernel gamma basically helps us identifying or controlling the overfitness of our model onto our data. So if the value of the gamma is high, then there will be overfitting of the model, although if it's very low, then there is a high chance that the model will be loosely fit. So as a conservative value, we'll be using the value of 0.3 for this kernel gamma. Now let's see how this gives us what results does it give us. So based on our results, we can see that the radial basis function kernel did not perform very well on our data, and most of the values which were actually true have been identified as zeros, which means that they will not be subscribing to the campaign. So radial basis function did not perform well on this particular data set. However, we saw that how we can implement the radial basis function in Rapidminer on any of the data sets. Thank you.